welcome to today's lesson, which is on double-bounded inequalities. So first of all, we're going to start off with understanding what an integer is. Now, if you've seen one of the earlier videos, we have actually spoke about this. An integer is any whole number, positive or negative. So it can be anything. It could be 1, it could be 3, it could be 100, it could be negative 100, but it can't be things like 2.5. It can't be negative 2.5. It has to be a whole number. So it's worth knowing what an integer is first of all. So let's have a look at this first question then. If you have seen one of the earlier videos, we did do something similar to this, but we need this later on in the video, so I thought it's worth just a little bit of a recap on this one. Now it says, and notice that these are both from past paper questions, so they do actually come up, these ones. N is an integer, so a whole number, and and it's negative 1 is less than or equal to n is less than 4. Brilliant. List all the possible values of n. Now, we can represent this as a number line if you want to. We'll do that quickly just so you can see. So if this one would be from negative 1, 0, 1, 2, 3, and 4. And because this is a less than or equal to, it needs to be a closed dot on this side, all the way up to 4, but not including 4. Okay, so that's a little sketch of the number line. Now with this one, it's asking for the integers which are satisfied by this, which means what are the integers within this boundary? So we know it's between negative 1 and 4, but not including 4 because it's not equal to there. That's the important part. So if I was just going to write the integers, it's going to be negative 1, 0, 1, 2, and 3. So it's all of these numbers in between this, including negative 1 because it's equal to there, but not including 4 because it's not equal to there. Brilliant. So just so you can get a bit of a recap, pause now and have a little go at that one on the right hand side. So pause now and have a go at that one. Okay, so let's have a look at this one together then. So this one starts at negative 3, which is less than k, which is less than or equal to 2. Now you don't need to draw the diagram for this, but I am going to draw it just because I think it helps us understand it a little bit. So here I'm starting with negative 3, and I'm going all the way up to 2. So it's going to be negative 3, negative 2, negative 1, 0, 1, and 2. Now this one here is less than or equal to, so I need a closed dot there, and I need an open dot on this one here, like so. So with this, it's everything between negative 3 and 2, including 2, because it's equal to, but not including negative 3. So it's just starts with negative 2, negative 1, 0, 1, and 2. So these are all the integers, the whole numbers that satisfy this, and that's worth 2 marks, which is quite a lot. Okay, so let's just check those answers. Brilliant. Okay, so next we're going to have a look at solving double-bounded inequalities. Now, a lot of people get a bit scared of these, but it's just because they haven't seen them before. It's not, or people forget how to do it, but it is really simple. When you're solving double-bounded inequalities, it's almost exactly the same as solving normal inequalities, which is almost exactly the same as solving equations. The only difference is you're doing it to 3 sections instead of the 2 halves. So let's have a look at this first question. So this one here is example 3 now. Do make sure you're getting these in your notes. Remember, the only way to learn maths is to do it. So I've got negative 2 is less than or equal to x plus 6, which is less than 4. Now this is the key part in the middle here. Again, we want x on its own in the middle. So to get x on its own in the middle, I need to get rid of this plus 6. So how do I get rid of a plus 6? Well, we know that we get rid of a plus 6 by subtracting 6. However, we need to subtract it from 1, 2, 3 sections. We need to do the same to all of these parts. So it's subtract 6, subtract 6, subtract 6, just like that, okay? So negative 2 subtract 6 is negative 8. Keeping the symbols the same, I haven't mentioned that yet, but these symbols need to stay the same, which is less than or equal to, they will cancel, so you're just left with x, which is less than or equal to, well, 4 take away 6 is less than negative 2. I think I said less than or equal to there. Make sure that symbol stays the same, so it's got to stay the same as less than. And that's that question done. Okay. If we wanted to, we could draw that, and I will draw a little sketch of it just to, because we will need that later on. So it's between negative 8 and negative 2. It's closed dot here, all the way up to negative 2, which is an open dot. I don't need to fill those in. Okay, so have a go at that question on the right-hand side. Notice that it is a past paper question, so this has come up before. So pause now and have a little go at that one on the right. Okay, so let's have a go at this one together then. Nice and straightforward, this, if you know how to do it. So this one's example 4. So we've got 3 is less than or equal to x plus 4 is less than 7. So I'm going to subtract 4 from all of these. Nice and straightforward. Minus 4, subtract 4, subtract 4. So 3 subtract 4 is negative 1, which is less than. They will cancel, so you're just left with x. 4 subtract 4 is 3, and there's your answer. Let's just check that. So they've wrote it here. If you notice, I'll just zoom in a little bit on that. So you can see at the top they've written it as a split, but the mark scheme wants it joined, okay? So it's negative 1, it's less than or equal to x, it's less than 3. So you can write it split. However, the mark scheme does want it joined, so it's better to write it joined. Okay. So let's move on to the next question then. Solve these inequalities. Now, you might just want to go ahead and have a go at some of these yourself. I think you probably know by now what you need to do, but I will go through this first one. So example 5. So it's only an extra step here. So 5 is less than or equal to 2x subtract 1 is less than 11. So here, first of all, the first thing I need to do, notice that it's 2x subtract 1. So what would I get rid of first with that? Well, I'd get rid of that negative subtract 1, 1, 9. And I do that by adding 1. And I need to add 1 to all 3 sections, exactly the same. So plus 1, plus 1, plus 1. So 5 plus 1 is 6, which is less than or equal to. They will cancel to leave you with 2x, which is less than 12, like so. And then to get rid of the 2, we need to divide by 2, divide by 2, divide by 2, divide by 2. So 6 divided by 2 is 3. 2x divided by 2 just leaves you with x. And 12 divided by 2 gives you 6. Brilliant. There we go. Okay, so again, pause now and have a little go at that one on the right-hand side there. Pause now and have a go at that one. Okay, let's go through it together then. So here we've got, this is example 6. Negative 1 is less than or equal to 2x. Subtract 3 is less than 5. First thing I'm going to do, add 3 to all 3 sections to get rid of that 3 there. So negative 1 plus 3 is 2, which is less than or equal to. That will cancel to just leave you with 2x, which is less than 5 plus 3, which is 8. Then, to get rid of the 2, I divide by 2 to all 3 sections. So 2 divided by 2 is 1. 2x divided by 2 is just x. And 8 divided by 2 is 4. I kind of glazed over the fact I'm keeping these symbols the same. I'm just going to recap that. It's important that you do it down like so, and that those symbols stay the same. Okay, let's just check those answers. Brilliant. They wrote it double, but we've seen the mark scheme. This mark scheme wants it as 1, so that's fine. Okay, so here we've got another question. Now, this is only a slight extension of what we've done with these. And I do see these come up quite regularly. Actually, this one was from the AQA in June 2015. Now, it's combining the two things that we know, solving an inequality or solving a double-bounded inequality and the integers. So looking at whole numbers, it actually calls them whole numbers here, but we know that they're called integers as well. So let's have a look at this one together. It's definitely worth getting this one down. We're on example, I think it's 7 now. Example 7. So 3 is less than 2n is less than or equal to 10. So the first thing we need to do is to solve this. It doesn't say to do that, but that's what we need to do. And I do that by getting rid of that 2 by dividing each of these parts by 2. Now, you can write as a fraction. You could write it as 3 over 2, but I'm actually going to do 3 divided by 2. So half of 3 is 1.5, which is less than or equal to 2n divided by 2 is just n, and 10 divided by 2 is 5. Now again, it doesn't ask you to draw it, but I think the drawing will help you with this. So if I draw my inequality, I'm starting at 1.5, so I'm going to start with 1 at my number line, and I'm going to go all the way up to 5. So 1, 2, 3, 4, 5. And actually, because I'm starting here at 1.5, it needs to be an open dot in between 1 and 2, and then all the way up to 5, which is there like so. Closed dot for 5 because it's less than or equal to there. This one's an open dot because it's just strictly less than. So, what are the integers that are satisfied by this? What are the whole numbers which are satisfied by this? Well, this is going to be the numbers which are between this, okay? Now, we're not including 1 because it's actually starting at 1.5. So the first number that we're going to include is 2, then 3, then 4, and then 5 as well because it's less than or equal to with a closed dot. So that means I am including that one. So the integers for this one would be 2, 3, 4, and 5. And I do see these questions come up more and more regularly at the moment. 2 marks, that's worth. Again, nice and straightforward if you remember how to do it. So let's just check that. 2, 3, 4, 5, brilliant. Okay. So, last little question now. Last little question. And this one is a little bit trickier. This one is only a little bit trickier because there's an added kind of element to this one. So, n is a negative integer. That is so important at the start of this. Okay, n is a negative integer. This is example 8. Write down all the possible values of n which satisfy that equation. Sorry, that inequality. So they're telling you 2 things here. So we've got to think about both of them. The fact that n is negative, and we've got that equation as well. So the first thing we're going to do is we're going to solve that equation. 2n plus 13 is greater than or equal to 6. Okay. So what we need to do is we need to solve this first of all. And I do that by subtracting 13. If I subtract 13 from the left-hand side, I'm just left with 2n. If I subtract 13 from the right-hand side, 6 take away 13 is negative 7. This was on the calculator paper, so we could have used a calculator for that one. So 6 subtract 13 is negative 7. Yeah, good. The next stage is we need to divide by 2. So divided by 2, 2n divided by 2 is just n, which is greater than, now negative 7 divided by 2, again you could write this as a fraction, but I'm actually just going to do it and write it as a decimal for now. So half of 7 is negative 3.5. Okay, half of negative 7, or negative 7 divided by 2. Brilliant. So we've got our inequality here, but we've got to think about that first part again, which shows that n is a negative integer. Now I am going to draw this. Again, you don't need to draw it, but I do think it helps. So starting at negative 4, negative 3, negative 2, negative 1, 0. I'm greater than or equal to negative 3.5. So I'm somewhere in between negative 4 and negative 3. And I'm greater than, so going right here like so. Brilliant. Now, n is a negative integer. So this continues forever, going 1, 2, 3, 4, 5, 6, all the way up to, well, as long as you can count. But we've got to think about the fact that this is a negative integer. So if n is negative, which of these are the negatives I've got? Well, the only ones which are satisfied by this, which are negative, are this negative 3, this negative 2, and this negative 1. Not negative 4, because we're greater than or equal to negative 3.5. So it's only these 3 here. Okay, so they're the ones I'd write. So if it's a negative integer, it's going to be -3, -2, -1, and that satisfies um, both of our statements. The fact that n is negative and this inequality here. Brilliant. So let's just check that answer. -3, -2, -1, super. Okay, so I've got some questions here for you to have a little go at. So pause now and have a little go at those. Okay, I'll pop the answers on. So mark those in green. Brilliant. So thank you for watching this video on double bounded inequalities. Do make sure you're having a go at the questions, because remember, the only way to learn maths is to do it, and have a lovely day.